Hi, RJ. Hi, Emma. I hope things are going well on your assignments and you're getting on and being able to complete them. I am going to try, I think, and shoot for 3 lessons a week, giving you 2 days just to work. This week has been a little bit funky because I didn't get started quite as like I'd like, but anytime you need an extension on your homework, I think I'd really like you to just let me know. Communicate with me. I would be happy to grant that. Also, remember when you're doing your homework assignments, you can always ask for a similar question, and that will also kind of help your grade in the long run. Today we're going to talk about 6.1, so let's go ahead and get started. We're going to talk about algebraic expressions and formulas. Now, before I get into the lesson, I wanted to do a little bit of review. Man, I can't even write today. So the order of operations for me was reviewed with what we call PEMDAS. PEMDAS. Okay, and that represents the parentheses, exponents, multiplication, division, addition, and subtraction. One thing that I want to point out is that the multiplication and division, when I did this with my kids, I always put it in parentheses, and same thing with the addition and subtraction. And then I would just put a line above it from left to right. Because if we're going to just quickly do an example, but this shows that if I have a division, that if I get it down to where it's division and multiplication left in my equation or expression, then I'm going to do it in left to right order. It doesn't mean that I do all multiplication first, followed by division. So let me show you an example. Let's say that I had 9 squared minus 72 divided by 6 squared plus 9 times 4. So the first thing you're going to do, we don't have any parentheses on this one, so we're going to do the exponents. So I'm going to indigo 9 squared, so that's going to be 81 minus 72 divided by 6 squared, which is 36, plus 9 times 4. So then my next thing that I'll need to do would be my multiplication division from left to right. And so what I like to do is I just go ahead and underline anywhere what I'm going to do first. So I'll start off with 81. Then I need to do 72 divided by 36. Well, 72 divided by 36 is 2, so I'm going to go minus 2. And then I'll also do 9 times 4, which is 36. And so my final answer, I will just go 81 minus 2 plus 36, which would be 115. Now, a couple of things that I wanted to again, talk about. There's some terms. Algebra uses letters called variables. Variables are just going to represent a set of numbers. An algebraic expression is a combination of variables and numbers that can be any of the operations with addition, subtraction, multiplication, or division, as well as obviously powers. Like if I have a number to a power is really just multiplication, but also roots. So remember, roots would be then like the square root. So remember the square root of 25, say, is going to be then 5. So these are some more examples of those algebraic expressions. Then what I'd like to do is I want to just jump in and start some of the problems. So on this one, they ask us to evaluate the expression, the 8x squared plus 17, when x is equal to 5. And it is an expression, and we'll talk a little bit more about that, but because it has no equal sign. So what we're going to do is just going to evaluate this expression. So I'm going to replace my x, I'm going to change it into 5. So I have 8 times 5 squared plus 17. Now it looks like a lot like the problem that we did earlier. So I'm going to start off nexting with my exponents, and so I'm going to go 8 times 25 plus 17. And then the next operation I'll do would be my multiplication. So I would have 8 times 25, which would be then 200 plus 17. So my final answer is 217. Remember too, I'm just going to give you, if I had the problem, if it was written 17 plus 8 x squared, I need to have the same answer. So 17 plus 8 times 5 squared. Remember, we would do then the multiplication here, the exponents plus the multiplication. So I'm still going to get 17 plus then 200, and I'm going to end up with the 217. So both of these expressions written in either way will make that true. The next problem that we have is we're going to practice just substituting it back into for x into a parentheses. So again, I'm going to replace this x with 6. So I have 7 plus 5 times 6 minus 4, all to the third power. So in this case, this is where I'm going to start off with my parentheses. So I'm going to start off by doing this operation first. So 6 minus 4, I'm going to just save some time and just cross it off and just put a 2. But this means I'm going to have 2 then to the third power. And 2 times 2 to the third power would be 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8. So I have 7 plus 5 times 8. And then I'm going to end up then doing my multiplication next. So that's going to be 5 times 8 is 40, plus 7 would give me then 47. On the next one, we evaluate when we're dealing with negatives. Negatives will give students some problems sometimes, but we need to remember that we treat the value when it's a negative, just that it's, we can't lose that. So let's start off. We have -6. We have -2 expression squared minus 11 times -2. Minus 17. So again, first operation things we're going to do is going to go ahead and do the exponents. But when I substitute that in, I'm going to end up with -2 times -2. And this part right here then will change then to a +4. But I still have this -6. So -6 times 4. Now when I have then I'll still have the minus 11 times a -2 minus 17. The next step is my multiplication, so then I'm going to end up doing these operations next. So I have -6 times 4. Remember, one negative times a positive is going to be then a negative. So I have a -24. This one, I have two numbers that have two negative values in front of it, and that's how I usually end it. So when I have a negative times a negative, that is also a positive. So then it'll have a value of a positive 22, and then I'll have minus 17. So when you put this into the calculator, you'll have a -24 plus 22, that's a -2. -2 minus 17 will be a -19. For the next problem, when we substitute two variables in, we'll have 2 times a -2 plus 3 times 4 over a -2 plus 1. And so again, I'm going to work the same operations. I'll have 2 times a -2, which is going to be now a -4, plus I'll have then 3 times 4, which is 12, all over -2 plus 1. -2 plus 1 is going to be the -1. And then my final answer will have 8 over -1, so I end up with a -8. When we do a few of there's a couple of terms that I'd really like you to know. The difference between an expression and an equation would be the fact that you have an equal sign, okay? And you can work and you can operate on both sides. We'll have some problems later where we're going to manipulate and work and solve variables, and those are usually when after we have an equation. A formula is an equation that uses letters to express a relationship between two or more variables. Still can be an equation, but sometimes it'll also, can also, I guess I'm not thinking of time that it's never an equal sign. Mathematical modeling is going to be the finding a formula to decide the real world phenomena. And so the example that they gave is the difference from Celsius to Fahrenheit and the conversion rate. So in order to do this, to find the conversion rate, it says use the formula to convert 86 degrees Fahrenheit to Celsius. So that means we're just going to go Celsius is equal to 5/9 times my Fahrenheit, which is 86, minus 32. And I'm plugging it back into my formula. So 86 minus 32, so I have 5/9 times 54. And then 9 goes into 54 6 times. So 6 times 5 then is going to be then 30. And then it would be 30 degrees. Then in this case, it's going to be Celsius. The other terms that we need to know, when we have expressions or we have things that we've been working on, we call each of those terms, each of the parts. For example, in the expression 7x minus 9y minus 3, you have 3 different terms that you're working with. They can be separated with either an addition or subtraction sign. The coefficients in front are the numbers that are multiplied times your variables. And so when we talk about a coefficient from the problem before, the 7 is a coefficient and so is a -9. The -9 is a coefficient for y. The constant would be a term that is not multiplied times one of your variables. So in this case, 3, which since it doesn't have an x or a y, it's being multiplied to, would be your constant term. And like terms are going to be ones that are the same. So what they need to be is going to be, for instance, like when I have 7x minus 9y, those are not like terms because they have 2 different variables. But if I have 7x and 3x, I know that those are considered like variables because they have the same variable and the variable is the same power. So if I said we wanted to combine like terms between 7x and 3x, then you would say that you have then 10x. Keep in mind, if I would have 7x plus 3x squared and I wanted to evaluate this one, they're not considered like terms because of the fact that this was to the first power, which we assume, but this second one is to the second power. And so this is as simplified as you can make this expression. So just know, and you can also subtract coefficients. For instance, if I had 7x minus 3x, then I would just subtract the coefficients here. And so a 7 minus 3 would be then 4x. Factors are going to be parts that are multiplied. So again, if we go back to the 7x and the 3x, we have a factor of 7, I have a factor of x. And this one, I have a factor of 3, and I have a factor of x. So it's parts that are multiplied. A lot of times we do talk about, like if I say I have a factor, and let's just go ahead and say I have the number 12. I have several factors in 12 because I know that I could break this down into 1 times 12. And I'm going to leave a little room here because what I'm going to do is I'm going to fill them in. So the factors of 12 would be 1 and 12. Then I go up to 2, and 2 and 6 would be then factors of each other. And then the last ones, 3 and 4, are also factors. So factors are going to be things that are multiplied together to give you that number. All right. So properties, we have several properties that we're dealing with. Commutative means that it will be the same. Community property of addition means you can add numbers. For instance, if I had, so they say A plus B equals B plus A. In other words, if I even put numbers in, that kind of makes sense. If I have 3 plus 2 is going to be the same as 2 plus 3. But you can also do that with expressions or terms. Commutative property of multiplication means the same thing as that we had before. Same thing goes if I have 3 times 2 is going to be the same as 2 times 3. The associative property of addition means that I can group them in any order and that they're going to have the same value. So, in other words, if I start off and I do the A plus B first, followed by the B plus C. For instance, let's just say that we have the expression, we have 2 plus 3 plus 4 should equal 2 plus 3 plus 4. In other words, what you would do here is you're going to go 2 plus 3, which is 5, and then add 4. And then this one, you would take 3 plus 4 and get 7 and add 2. So in other words, they have the same value. Simplifying algebraic expressions. First, identify whether or not you have like terms. And so when we have an x squared and an 5x squared and a minus 8x squared, the x squareds indicate that they're like expressions. So then we have to identify the coefficients, and here are your coefficients. And once you get to this point, then you just simply add or subtract the coefficients. So 5 minus 8 would be then negative 3, and then you add in the x squared. So the answer to this one is negative 3x squared. If you're simplifying this expression, when you have parentheses, start off by distributing and to get rid of your parentheses. So 5 times 3x would be 15x. 5 times a negative 7 would be a minus 35. And then I have that negative 6x that's floating around. Now I looked for my like terms, and I have like terms of 15x and 6x. So I'm going to start off by just combining those. But remember, the value in front of the 6 is negative, so I need to make sure I keep that. So I'm really going to take 15 minus 6, and that's going to end up being 9x minus 35. The last example from that I have is going to be this one where I distribute first the 3. So I'm going to start off with 3 times a negative 4, which is a negative 12x squared. 3 times 5 is going to be 15x. Now, when you have a negative in front of the parentheses, you're still distributing a negative. And if you want to think about it like you're multiplying through times a negative 1, then that's acceptable too. But when I distribute the negative through, that means the first one, because the 5x inside my parentheses is positive, I'm going to drop it down and I'm going to make it negative. So I have a minus 5x. The value in front of the 4x squared is negative, and so when I distribute my negative into that, it's going to make it and change it to a positive 4x squared. Now I'm looking for like terms. I know my like terms here will be the x squared, and then I'll also have another set of like terms with the 5x and the 15x. So I'm going to start off with a negative 12x squared plus 4x would be a negative 8x squared. And the 15x minus 5x is going to be a positive 10x. Now the last thing, I looked over your homework assignment, and I wanted to give you a little heads up on a couple of problems. Now you won't get exactly the same ones that like the numbers that I have, but if you look at question number 2, the one that I was looking at, it had 8 plus z is equal to 20, and they ask you to solve for z using the addition property. Now we know that on simple equations like this, if I have an 8 plus z, in order to solve for z, I would want to do the opposite, whatever's happening. So if we're adding 8 to z, we want to subtract 8. So I'm going to subtract 8 from this side, but then I'm going to find my equation. I'm going to go on the other side and make sure I subtract 8 as well. So in this case, my 8s will cancel, and I'm left with just z. So z then is going to be 20 minus 8, and that would be my answer is 12. Now what they did is they asked us to put it in a solution set. So they've got a bracket. And in this case, because the only time when we deal with a range of numbers is when we have a greater than or less than sign. And when it's equal to, you'll have only one number in there, and you would just put that your solution set would be 12. Now the other one, on question number 13, they used the formula using velocities and initial heights. And they gave it that an object is tossed, and that they have an equation h equals, then in my case it was 2 plus 65t minus 16t squared. And what's nice, this is another quadratic formula, and you use this quite a bit when you get into some of the upper level math, but they ask you to find the height when t is equal to 3. Well, this is no different than the problems we had before. We're just going to substitute 3 for t into my equation. So I'm going to have 2 plus 65 times 3 minus 16 times 3 squared. And then you're going to work this problem just like you've had before, okay? That takes care of the lesson. Good luck. Hopefully we will be communicating and hope you won't have any problems with it. Have a great day.